Good afternoon, dear colleague. Thank you for joining. Welcome to the next session for the Cloud Monitoring Tuesday. Welcome Dubai, welcome Qatar, welcome Abu Dhabi, yes, Dubai, UAE, Qatar and Saudi Arabia. Thank you for joining. And today we continue our journey through the Azure Monitoring. We will talk about the specific KUSTO request for the different services. We will talk about virtual machines. We will talk about backup and storage monitoring, how you can analyze it, how you can work with it, and who joined it our meeting first time. My name is Igor Shestitka. I'm Microsoft MVP. You can see my roles. You can see my companies or where I work for. And also you can find me by email. Also this video and another video recording of my events in my webcasts and the recorded video you can find on my YouTube channel. By the way, below the video there is description of the video, so you can find the links to another videos that's in this series or on another series. You're welcome, and also welcome, you can find me on LinkedIn directly by name or by this email. You are welcome. And let's continue. As I mentioned, we have the really long cloud monitoring journey. It's it's like exactly the middle, from the August until September. Today we will talk about the KUSTO language request, specific KUSTO language request. It's hands-on experience session today. Next meeting we will talk about the same, but to talk about the networking, about the application gateway, about the ExpressRoute, how to work with this, and also about PowerShell automation, runbooks, and how to work with PowerShell automation and run the runbooks against the log analytics. And the last session, it will be the session that will cover all our steps: how to configure automation, how to use modules, how to use manage identity with log analytics, and how to set up all logging based on the Azure Policy. So this is our journey, and today's topic, we will look how to configure the diagnostic settings for required object, because we are planning to understand how to work with the VM logs, with backup logs and storage on the log analytics. So this is our topics today, and I would like to remind you about some additional information. We are talking about the Azure Monitor and log analytics, from where and how the logs collected to the log analytics. If you look on these diagrams, when we are talking about the subscription or resource level, there is metrics and resource logs that could be collected by configuring the solution to the logs or to the storage or to the event hub. We will talk about this later, exactly how to configure. About resources, we are talking about resources like a storage account or backups. We will look on it. Same way, when we are talking about the virtual machines, inside the virtual machines you have not only the basic metrics and resource log of the virtual machines, but you have operation system and you can collect the operation system logs and additional information based on the guest agents. These agents, you can see it's Azure Monitor agents or log analytics agents. Log analytic agents, it's already depreciated and it's like a legacy agent, but for the Azure Monitor agent, it's a new one and allow you to send the data to the metrics or send the data to the logs. We will look how to configure it and what is the difference between two agents to work with this. And plus we will look a little bit about the dependency agents. So this is how exactly logs from operation system, because today we are talking about the virtual machines, logs, any records, performance records, comes to the logs itself. And the first part is exactly the demo, how to configure log analytics for objects like VM, backup, and storages. There is some difference, and before we'll talk about what is the data collection rules and what is the transformation rules inside the data collection rules. Let's switch to the here. Let's switch to our solution, and here we have Monitor, and one of the options inside the Azure Monitor is the data collection rules. What is the data collection rules? These data collection rules provide you the different way how you can collect different data and send somewhere. So data collection rule is the tool that stands between the Azure Monitor agent and log analytics, because you don't need to configure exactly the information where you have to send the data in terms of log analytics. It will be configured like a proxy for the data collection rule. You don't need to say for the inside the agent what exactly you want to configure, because today you want to configure one parameters, another day you want to change these parameters, etc. And it's exactly the data collection rule option. If you look on the existing data collection rule, you can see at first the data sources from where we are collecting the data, and you can see that we are collecting the data from the performance counters. We can collect additional information, etc. So this is exactly what we are collecting. Plus we can add additional data sources by type. It could be the Windows event log or Linux syslog to collect. And plus we have here the destination. Based on the destination, we can define what exactly will it be Azure Monitor log or Azure Monitor metric. It's a new option in preview, which subscription will be used and which log analytics will be used. So this is exactly the options. And in the other hand, we have resources that's associated there. And these resources, it's exactly the virtual machines that send the data that we needed to the system. Plus you can see that it's not only information about the virtual machines, but also you can build collection endpoints that could be used, assign the collection endpoints that could be used to collect this data directly inside infrastructure. So one of this issue, well-known issue, when it's talking about the open ports, when you don't want to, for the virtual machines to send data outside virtual networks to any other APs, it's exactly the response by creating collection endpoint. And this collection endpoint could be utilized and mapped to the corresponding log analytics, so virtual machines will send the data directly here. If we need to create additional one, so like it's really easy to create. You see what exactly we are planning to collect. At first, the name of the rule, DCR Igor SH 0. Today is 13 19. Hope it will work. For 13th of September, we can define the where we will place these rules, which region will be used, West Europe, and which platform we are looking for. So, like, for example, to collect the data from the Windows. Again, so we create the same rules, what we need, which resources we will be used. We can assign directly. We don't want to collect add the resources right now, but we want to add the sources, and this source will be performance counters. Let's say extended performance counters. It will be added here, and also I want to add the log analytics, and I want to add, so like you see, you can add the XPath for each query inside the machine. So like it means that any event logs by XPath could be added here, or we can add some basic requests like for example, application error, failed audits, and critical errors, and critical errors for the system. Add data sources. Oops, sorry, I choose wrong destination. Here it will be log analytics here and workspace as expected. We don't need to put the tables inside the log analytics because it will be predefined. So data collection rule validated, ready to use, and we are able to assign it if it's required. So done. To be sure that this data collection works works normally, so we can look on it again, look to the resources, and better understand what's going on in resources based on its log. When it's this log analytics sent, it's easiest way to see over the performance. When we use insights, if we see these tables and these tables fill it out, it means that all works fine. Same for the mapping, for the networking. So data collected normally based on this resource, based on these rules to monitor. From another hand, we can see all our clients that's collecting the data through the log analytics workspace. So like if we go to the log analytics workspaces, here I have two workspaces. One of it is this one, mine, and we can see agent management, and we can see that 3 Windows machine already connected by Azure Monitor and 1 by legacy agent. Linux servers, we have no one. It's strange, but anyway, we have no one Linux servers connected. We can check it by the request, and it's really no one of the machine sends the data. Anyway, so this is the way how we can control. We can see data rules that's associated with this log analytics, how it works, where it's placed, etc. And we can see the old one, legacy client configuration, how to configure and work with it. Okay, so this is from the log analytics works. Let's do the same from the client perspective. I deployed the new machine, just one small Windows machine, and I want to send the data to the log analytics, to have the logs, to have the information, etc. So to do this, you can do or by capabilities, by configuring these insights here or by configuring directly on the monitoring. Let's do on the inside. It will be bigger picture. So just enough to click enable, and there is a question how I want to configure my monitoring settings. I would like to install Log Analytics or Log Agent. Log Analytics Agent does not ask you about the configuration, etc., just a Log Analytics workspace. But for the Azure Monitor Agent, you need to provide predefined and already compatible rules, like you can see here, default collection policy, this one, that allow us to collect the guest performance, process and dependencies, and will send this data to the Log Analytics. It's again when we go here, and this one is it. It's exactly our configuration that we discussed before. This is my performance counters that I want to collect, etc. To work on it. And so what is our next step? We just click configure. What will happen? Agent inside virtual machine will be installed. So Azure right now is pushing this configuration, and agent will be connected to data collection rule, and after that this data collection rule will be applied, and only required data will be sent to the configuration. That's all. So like we don't need to do nothing special, then choose the right collection. From another perspective, when we are talking about the different objects, I mean, for example, backups or storage accounts, if we want to configure the storage accounts and send the data as required, we need to configure the storage account. Just a second, we will find at least one. Cloud Shell, no. Let's take this one, TF Storage RG, TFSA. Let's see the containers. TF state, okay. So this is one of the containers. To send the data from this container to the Log Analytics, there is insights. You can see this insights that's configured automatically with the system, and we can configure additional information about the storage account, what we need to send. So like inside, it's just like a metrics, right? But if you want to have detailed information about operations, detailed information about the options, etc., so welcome to the diagnostic settings, and you can see the diagnostic settings is turned off, but we can turn on diagnostic settings by turning on the what is the name, Terraform storage account all, and send it to the Log Analytics based on this configuration. FF, whatever. So these diagnostic settings will be turned on, and additional information about transaction will be sent. If we need additional information about the blobs, tables, or files, it means that we need to add more information like logs about the read, logs about the write, log about the delete, and send this to another same one, but with another options and another diagnostic TFSA blobs. By the way, these options also are used when you send the data to the event hub to do the real-time monitoring and get the events for real-time monitoring inside the storage account to react. For example, you want to react that file is copied, and so blob is copied inside the storage account, and you need to immediately do some actions. You can do this by event hub and part the event hub. But anyway, for this one, we are configuring the blob to have this information about the blob and what's going on inside the blobs. So this is another option that could help you to understand. The same one, because we are talking about the, for example, backups. If we look for the backups, no, here. If we look for the backups, oops, no backups. Yeah, here. If you look for the backups, on the backups, I think I already configured it. Yes, but anyway, so you can see that's how you can collect and push the data to the backups the same way by configuring the system. So this is exactly the way how you can configure the data. After that, all data will, let's see for the Windows 2, after we did enablement, let's refresh it. And you can see the data is collecting the information about the data, about the health, about the performance, etc. It's strange why it's saying that I'm using the log analytics agent, because I'm configuring the Azure log. Yeah, it's Azure Monitor agent, not Azure Log Analytics. Maybe because it's on preview, but anyway, so we can check it again by Log Analytics Workspace and go here, go to the agents, and can see that we have already 4 virtual machines that's reporting us to the system, and this machine Win2 is already here. The version, all of this stuff you can see works perfectly. Resource groups in place, all information in place, so like it works fine. Anyway, what we are planning to do next, it's exactly discuss how to work with this environment and how you can use this environment to do the monitoring, to understand what's going on with virtual machines, etc., etc. And this is exactly about next slide, KUSTO and language and exactly the queries. We talked about the KUSTO language previous session. There is like just a notification, maybe you missed this. That's like, do I need to learn KUSTO before start to work with Azure Log Analytics? Not exactly. Again, if you understand the, for example, SQL query language or something like this, it's really easy to understand the KUSTO language, but it's more important to understand how the data structured and which tables we have to look to understand what's going on inside the Azure and inside the logs. The same way, like if you know the SQL, there is a link to the cross-reference between SQL and KQL, KUSTO query language, right? So you can check it. And more important to understand how to parse the data, how to work with this, do the operations, how to work with the forecasting, how to work with table joining and rendering. It's more important. And again, so like most important part, and we will concentrate today on this part, it's working with VM inside. What I mean by VM inside, it's exactly the tables that provide the information, and it's not one table. You need to look on the repository or Microsoft documentation what is inside metrics, which data could be provided, and how to manipulate this data. We will work with the Azure Monitor log analytics tool that allow us to create the query, record the query, and save the query, and after that execute, debug, etc. If you need to work, if you want to work locally, you can use the Visual Studio Code with KUSTO extension, and you can call. After that, we will talk about this later on after the next session. We will talk about how to work with PowerShells, with inline code, with this solution. So this is exactly the questions, and let's back to the typical KQL VM query, how it looks like, where the data storages, and why it's important to understand. But before any questions, if you have some questions, please put on the chat, or you can use the reaction tool on the Teams, just reaction, and you put the raise the hand if you have a question. If there is no questions, I will continue. So if there is no questions, let's go one by one to better understand the options and how it will work, etc. When we are talking about the virtual machines, all data about the virtual machines mostly no, VM inside, it's a solution. It will not go depreciated because it's a solution that's based on the table, etc. It's not like a, let's say, gold, it's depreciated, because tables anyway will be the same. Right now, when we are talking about the agent monitor, Azure Monitor agent, the configuration will be the same. And again, when we're talking about the logs, when we go to the logs here, you will see, you see this query, by the way, that we did before, and you will see exactly the tables or groups of tables. As you can see, Azure Monitor for VMs, it's inside metrics, and anyway Azure Resources also inside metrics, and inside metrics one of the most important table, because you can see the log inside metrics also on the log management. You can see inside metrics, inside service maps, etc. So a lot of resources use the inside metrics like a table. So like, just imagine that we are abstracting against from the virtual machine but to the database. So right now we are working with the database that's provided by the log analytics. So it's just a huge database, and when we are doing the inside metrics, we can just double click on the insight metrics and run it. And what we will have here, we will have a lot of data for 24 hours. You can see we are trying to get all this data required for the system. Where you are? Just waiting. It was a bad idea. Let's take it with 1 hour and see to the... So for 1 hour you can see 7,000 events inside this metrics. Most of these events have the two origin or exactly information about system performance, etc., or you can see the maps that provide us heartbeat, etc., to better understand what's going on with the system itself. But anyway, most of it you see it's just one origin, and after that all data inside, when we are talking about the virtual machines and configuration, stored in a few important columns. First one, it's a computer, so the computer name that we are talking about. There is some, let's say, issue when you name the computer. You see with the names longer than 15, you know, that's limitation of the Windows. 15 characters, it will be coded inside the log analytics, unfortunately. So try to name the machines as expected. A second one, so like it's a computer name. Second one, we have namespace and name. Namespace provide us information about the resource that we are monitoring, like logical disk, like CPU, like memory, like networking, etc. Second one, provide us additional information about the name of the counter inside the namespace, like free space, percentage, heartbeat, you see, latency, etc., etc. After that, we have the value for this one. But it's really important to understand that value, for example, free space percentage for the disk, logical disk could be A, B, C, D, E, not A, but C, D, right? E, etc., or mount points in Linux. And here we have exactly the information in text, you see, about what objects inside logical disk we are talking about. So disk C is hidden inside text. When we are talking about the available memory, the full size of available memory are here. When we are talking about the logical disk free space in megabytes, not on percentage, the free space of the disk, full space of the disk also is hidden here, you see. So for example, to better review it, we can do like this. So it means that this option provides us additional level of, let's say, query that we need to work with to understand what's going on. And if we look on the first query, when we are talking about the insight metrics, we take the data, for example, from the time generated. Time generated, it always exists for any log analytics query, for any log analytics table. Time generated when the record, it's not about when the event happens, but it's when this record was created. If events required the information about the timing inside event, it should be presented like a separate column. But this one, do not trust that this happens this time. No, it's not event, it's just a record. It was recorded that time, but maybe it contains information a few seconds or maybe even minutes before. You see. But anyway, back to the to our typical query. We are talking about the insight metrics. We take the data. We take the data between the ago, 1 day ago, and 0 minutes from now to back to the 1 day, or we can put it. It's because typically we need to check not like a 1 day before, but some period of time. We can put this period of time, or we can just take it like time generated greater than ago 1 day in this case, right? But it's just like a placement to put some anytime blockers. And look, we take the namespace memory and available memory, put this available memory like, and it will take like here filter contains memory. You see, second one, filter contains available memory. We're ready. We take this data. This data contains the current value and full data, full memory. To get the full memory, what we are doing the parsed JSON for the text. And send this, you see, we are doing the extension, send this data to D, like just a data, right? And we will have the parsed, not like a string, but parsed JSON. And it means that we can work with the D like array based on the parameters inside the JSON. So we have this JSON like this attribute VM size. So to D like array, name it array, we can address each data by the exactly the tag name. So this is the tag name. To real, we will have memory size that's provided fully. After that, we are doing the summarizing based on the count. We are calculating the count of how many time machine sends this request. We are doing the average of the value, or we can do, for example, min max, and the average of the memory size typically does not change, but maybe sometimes you change it by computer, by namespace and name. So we are doing like this, and after that sort by computer, etc. What will happen if we run this? Yep, correct. We will see exactly the data for the memory. How to run this query? Easy way. We put it, let's say, not 1 day, but let's do the 3 days or 10 days, whatever. We want to see it. We want to see not average, but let's do the minimum and maximum of value. And run. You can see 3 PC, why 3 should be 4, but maybe 2 machines with the same name, because monitoring 001 and monitoring 003. It's weird, but anyway, yeah, it's happened. We can see this is Windows 001. You can see that number of the counts, definitely this is 2 machines. Average memory size, it's 6 gigabytes. This one is 8, this one is 8. It's how exactly it's presented in Azure. Maximum value for this one, minimum value for this one, so available memory. This machine does not utilize memory. This machine does not utilize memory like too much, but we can see the situation between the, so like this way how we can do exactly monitoring of the virtual machines itself. Questions? Okay, if there is no questions, how we can do the optimizing to work with the, for example, disk free space. Let's do again, so like what typically I do to understand what I need. At first I put, for example, logical disk. I can see different logical operations. I can put that I need my free space in megabytes. Okay, so this is exactly what I need. So like I can modify my request to the logical disk free space in megabytes, free space megabytes. After that I need to get additional data. I need this one like a free space megabyte to get the current megabytes inside the machine, inside the disk. But same time the drive itself will be the different. Extend dname, let's say drive name will be toString because we are operating with the parsed information, and here I will put what? I will put the drive name. To take this drive name, I need this mount ID. Why? Copy. Mount ID, so it will be the drive name. And next one, it will be dname, drive name. After that we will summarize by so group to summarize by drive name, different drive, different summarizing computer name, namespace, and name. In reality we don't need this name and whatever, but I want to have it here on the results, and I need it inside my summarizing. So it will be sorted by computer. After that, inside the computer we are planning to sort by dname, is ascending, namespace, and go. Ta-da! So you can see information about these machines, and you can see that each machine has the 2 drives. One drive is exactly 1C, another D. It's a temporary drive that's Windows added. The sizes of temporary drive presented here. The sizes of the maximum value is different one. Sorry, no. This one, the normal one, the maximum when the system just starts, the minimum, it's current, let's say, data, maybe, or not. But it is how you can manipulate with this data, with virtual machines and information about the virtual machines. From another hand, what we can do, let's do with, I lost the presentation, sorry. This one, it's really often query about the heartbeat, for example. This query, by the way, configured to use inside the workbook because this hours it's presented the number of the hours in format how parameters inside workbooks presented. So this is the question, but anyway we can run this request too. Give me a second and let's do another query. And let's say we are planning to have SLA for 2 hours, heartbeat 2 hours, and origin should be like this one, and we don't need this one, just one of origins. And we will do the SLA, right? Before do the SLA, we need the total count -1 because always we lost one heartbeat because machine if you it's write it means one it's gone, right? And we can run this request here and you can see the SLA. I told you that's like this is a double machines, each of it. You see the SLA for the Windows machine it's 0102 001002. This one it's also 001002, and it's why we have this high SLA because this one. But this machine it's just started to report and we have SLA 23.25 because for 2 hours it's not enough. But anyway, this is easiest way to do the SLA and do the configuration, except another thing that allow us to for example render it. When we have this render time chart, you see we are doing the by computer, this computer, this computer, this computer, by different SLAs, or render it will be better maybe by bar chart like this one, and you will see the different SLA for different machines inside the system. Is it clear? Any useful? Okay, if it is, we have just 10 minutes left and I need to provide a lot of additional information. The next one, it's a backup query. You can see a few backup query. One is most useful because it's exactly about backup. When you're doing the backups and operations are complete or not complete, you can look on the complete status based on this additional Azure backup jobs. This is a special table. I run the backups before start these meetings. Let's see what's going on. Oops, sorry, policy items. It's still initiated backup. It means that we will not see. But anyway, you can see the easiest way to do the backups to check it based on the job unique UID. This is the identifier. You can take the average max last backup. You can take the job and have the information about the job, failed status, the failure code is if it's required, it will be succeeded, or failed if the status completed, so like it's only completed. If you need state all, you just don't need to go with this option duration in seconds, data transferred in megabytes, etc. If you are looking about more complicated solutions, like, for example, Azure Site Recovery, you can see this option in Azure Diagnostic, name it A2A Provider. A2A, it's Azure to Azure, right? To work with the information about current replication. You can find which virtual machines, from where, what is the status of this replication, what is the RPO in seconds for this replication, what is test failover status, etc. All this information could be configured and provided by, for example, RPO in seconds. Another request will help you to build the diagrams, like a bar chart diagrams, but these bar chart diagrams will be configured like 15 minutes, 1 minute, etc. You see, I'm extending by case. In case of RPO, for example, right now less than 16 seconds, it's less than 1 minute, 3 minutes, 5 minutes, 10 minutes, etc. So it means that RPO will be configured like records, right? These records, or even more than 30 minutes, so it will be the value of RPO. And after that, we are planning to project it and render it like a bar chart. And this bar chart will contain the number, because we are trying to summarize it. It will be number of the RPO in each bar, so by count, you see. And after that, we will have the full details of the backup. From the easiest part, let's go to the, because again, I run out of time, let's go to the more interesting parts in the VM disk, for example, controlling query. What it means? It means that here we can look on the disk sizes and compare the disk sizes between existing current value and previous value, what was happened and what's happened before. So we are using, you see, the standard requests that we had before, like we take the logical disk and free space, we take the disk drive, disk size, all of this stuff we take here, and after that we compare the value less than 15%, and if it's less than 15, we are trying to understand what exactly happens and what size was before, not 1 hour before, but 2 hours before, 3 hours before. Like we are moving the window to compare between first hour and second hour, to compare how fast the data is dropping. To use this solution and how it will work for us, it's again quite easiest solution itself. Let's do the next query. It will be empty by default because there is no any sizes less than 15%. It's just like, you know, the changing less than 15%, we need to send some additional information. Why it's changing? It was the normal changing, like or it was like non-predictable abnormal changes of the site. Let's do like 95% and we will see it. You see, so like we have the drive C for this machine 90% for what time? Minimum time for the minimum 91%. Before it was current, sorry, before, and current is 91, yeah, and the previous 91. So it's even better situation than previous one, you see. So like you can compare all this value itself by using this one, but this one, it's again just options when we need to report that something happened when we the size of the disk dropped less than some parameters. But we want to have this value not only because one parameter, but because again, so just less than 15%. But what happened? Is it normal or is it not normal? Do we need this? Do not need it? See, even we have not less. This is the how we can do. So the minimum value, maximum value, when it happens, current value, previous current value, previous minimum value from the previous window, previous option. So like all these settings, you can use it, define it, and control it to understand what's going on inside the system. This is one of the scenario. But another scenario, it's even more complex and more sophisticated, let's say, because we are working with the prediction itself. So for the prediction, we are doing the same before this line, but after that we are making series that at first we define it maximum and minimum that we have inside our range. So maximum of 10 days, minimum of 10 days. After that, look, we build this series, additional series from minimum to maximum plus 3 days with step 1 hour. It's important. With computer and drive name, it will be fill out like a computer drive name and FPS current minimum value, or 0 because we have no data for time plus 3 day time. But after that, based on this series, we are doing the forecasting that provide us with step 3 days split by 1 hour, 3 days by 1 hour, 3 days. And after that, we make this value extended by the index of the forecast, time generated, and exactly the series that we build. So we compare all this series after that, and time generated greater than now. Plus, we need to add the info, because this series will be just time generated, FPS, and forecast, nothing more. Forecast, right? Time generated, but we need to compare this data with existing data of the virtual machines, and we are using this information by computer name and drive summarized, right? And after that, provide the current information, current drive sizes, etc., based on these two joins here. In this case, what we can see, where is it? Strange. I lost this query, but don't worry. I have it exactly inside the PowerPoint. I can copy from the PowerPoint directly and put it here and run it, and ta-da! So you can see that prediction. What's some issue here? I know what's going on. Because this machine is stopped, we can't predict the normal size because, again, based on this information, the system is 0 or higher 0 or higher 0 or normal size, and this is the Y. But when machine is turned on, or you know the prediction range when it was stopped, when it was started, it will be the normal one. But anyway, because it is non-stopped, we can't predict the normal prediction, but anyway, it works normally. Plus, it's just not only one prediction that you can take. There is more sophisticated options that allow you to have the information about the machines and manipulate by the processes what's going on with the processes and what is the correlation between processes, utilization of the CPU, utilization of the memory, utilization of the disk. This query can help you do the deep dive performance root cost analysis in case of some events, like for example, one machine is we have the different tiers of the VMs, and you know that this tier works fine, this tiers work fine, and another tiers works fine, but in total it does not work normally. And what has happened? Is it a performance issue, or is it the issue with the memory? And we can correlate this situation with CPU, with process utilization, etc. You can see that we can take this data. Plus, we can take this data about the response between different tiers. So, like, we can control different tiers based on information inside the system, inside the connectivity. And if you look on it, for example, we want to analyze the sorry, we want to analyze the traffic to the machines. We want to analyze any, let's say, outbound traffic inside the machine. What's going on for last 8 hours. So what you can see here, you can see the machine, you can see the process name that's working inside this machine. You can see from where and where it is trying to connect. If it's to each other, we can get the relations between each other, or which process and where it's sent. So like if we compare here and here, the same one like inbound, we can correlate between the processes itself. So like you see, for example, health service in Win2 sends the data. This is IOPS, current IOPS, average IOPS, CPU utilization, memory max. So we see that machine is okay, but response time for our service is 99%. Maximum response 166. Current opened links 000, sum link 0, outbound total, outbound average, inbound total that sent back, etc. So based on this information, we can look what's going on with processes, what's going on with machines, which options are working there. And again, here we can put inbound and run it. No results, because we need to, no. So all direction is inbound. So we have no inbound traffic. Let's check it. We can just take it like this. And no, we have no inbound traffics at all for this virtual machine. So like just only outbound traffic inside the solution. So questions, because we a little bit run out of time and I have to drop for another meeting. If there's no questions, or is it? No questions. Aha. Yeah, definitely. You can create the alerts directly from this query, any query, and this demos exactly about the from the alerts. Most of it, for example, this is predictions. Space could be used like a prediction and send the data that it happens when you put exactly, for example, the where information after the prediction. So you don't need this part, but maybe yes, because you need additional information. But anyway, you can put the where additional and cut all other data then higher than, for example, 10% of free space, and you can predict it and send it, right? For this one, exactly the same, right? So like you can, you see it's, you send this when the current value exactly, I copied it exactly from the stuff. This one, it's also all about the query when you put, for example, not completed but failed, to generate the failed alert, etc. Or generate this one, it's just for the render bar chart to see better. It's for the workbooks, but this one, it's exactly you can do the alerts if your RPO greater than, for example, 300 seconds or greater than 5 minutes. It's a huge RPO and we need to look what's going on. The same for here. So like if your SLA greater than less than 99 or 95 .95, so yeah, 95, so you can generate the alerts. Any of it can be used here. All these queries you can find here, and also when this video will be published, I'm planning to put it inside the description of the video on YouTube channel, so you will be able to find it exactly under description, because when I tried to copy this, I already tried to copy this query to the chat, it says that it's dangerous and will not be copied. Looks like some, it's like a internal Teams firewall checked, because this looks like a comment. The slides will be shared too, yes, on the community page. So like, because it's my contacts, you can ping me, by the way, on the LinkedIn or whatever, and connect there, and I will send there. Anyway, so like all this data, all these videos will be published on Azure UAE, Azure Qatar, and Saudi Arabia, Saudi Azure community. I worked for UAE, I worked for Saudi, never worked for Qatar, but anyway. So in Saudi, I spent mostly like half of the year, exactly near this building and the mall near this, like it's not far away, hotel, and Microsoft office, by the way, also near this building. I don't remember the name of this building, but nice building. Anyway, so I worked for 3 years in UAE, but anyway, so you will find this announce where it will be posted, shared by Azure or Azure YouTube. Any other questions? You're welcome. Welcome to the next session. On the next session, I would remind you, we will talk the same, but about the networking we will look on the networking query, what is there and how it works and why it's important. Plus, we will talk about application gateway query, ExpressRoute, how you can look inside the application gateway, etc. Hope I will have a chance to deploy and do some activities inside application gateway, but anyway, I have predefined query from my customers. Unfortunately, I can't demonstrate the customer's environment but you can see the query and I will explain you how it works for ExpressRoute 2, plus how to generate some additional interesting things. Okay. Thank you. I see on my watches that I received 2 invitation. I will definitely accept it and share with you this data and this presentation. It will be even better. Okay, thank you guys. See you later. See you next Tuesday on the Cloud Monitoring Tuesday, 5 p.m. Dubai time. And good luck. And bye-bye.